Okay, this is the Cinder follow-up for our R17 mid-cycle from last week, and we've got Gorka to explain what's going on with the new quota system, and take it away.
Thanks. So, as I mentioned before, the idea of the spec is to change how the quota system works, but at the same time, we don't. One of the problems that we have with the quota is the complexity, okay? Because we are creating reservations, we are doing some work, then we have to commit the reservations and remove the reservations while changing it to commit usage. We also have that the complexity is one of the problems. Another of the problems is that we keep a counter of things that the resources, let's say 1 gigabyte, 2 gigabytes, we keep counting. So if at any point that goes out of sync, it is very difficult to resync it correctly because we also have reservations, and the reservations are not linked or tied to a specific operation. So yeah, we know there is a reservation for 1 gigabyte, but we don't know what operation reserved that and whether the operation failed or it is still ongoing. So resyncing the quota and fixing it is not easy. Another of the problems we have, besides the complexity, is that the quota system is, the code for the quota is spread everywhere in Cinder. You have a lot of code in the API where we start doing a lot of if this, then do that, and so on. And we also have it in the manager, we have it everywhere in our code. And every time we code some new feature or add something, we have to think whether we have to add the quota or not. We also have to be, when reviewing our code in general, it's really hard to see the high level flow of the code because there is a lot of quota stuff in the middle. You have, like, in the spec, I mentioned a specific case where there is a relatively large method, let's say 100 lines, and maybe 90 lines are quota stuff. So it's really hard to see the actual flow at a high level because all the quota is written there as well. So the idea with the spec is to do two things. Propose an alternative solution to the quota system. Instead of doing quotas and counting them, change it. We don't store the counting, we do it dynamically. We want to see if we would exceed the number of volumes. Then let's count how many volumes we currently have in the database. And we have the count, we see the limit, and we can compare them. But do it as a SQL query, the dynamic counting. That's the general idea. But it will also try to push the quota stuff down as much as possible. So instead of having it in the API, we will push it to the version objects. So when you say create an object, a volume, for example, it should automatically check the quota. You don't have to worry about how the quota works. You just say, I have my object, create the volume. Automatically, version object has the code to check the quota. So you no longer have to worry in any part of the Cinder code, and it's cleaner. Also, of course, we have temporary resources, but these temporary resources, we already added a field that is use quota. Having that field makes it possible for the version object to see if it has to check for quota or not. If it's temporary, it doesn't even bother to check the quota. It can just proceed to create it. This way, I think this proper abstraction makes it easier to read the code in general. What else? Yeah, and another aspect of the spec is that all these checks that we are going to have are going to be implemented in the driver as context managers. That way, we can use database transactions to do everything or nothing. It's all or nothing. So we don't turn into the current code problem where we submit a reservation, we follow up, something fails. You have to roll back the reservations. And you end up with a lot more code. If you use a transaction for the whole thing, you don't have to worry. If something raises an exception, the transaction is going to automatically be rolled back, and you can just move on. Lastly, the quota system is going to have, let's call them parameters that are more abstract than what we currently have. We currently use everywhere in the code where we use quota, in the API, in the manager, anywhere. It has to know that we have volume quotas specific to the type. You can restrict how many volumes you want to create, but you can also restrict how many of a specific volume type you allow. This means that throughout the code, we have to start constructing the resources that we want to check, the names of the limits, let's call it. Volumes is for volumes, but volumes underscore LVM could be for the volume type LVM. So throughout the code, everybody needs to know about this point, which is specific to the quota, and we have it throughout all the code. And I think it should be specific to should be considered internal quota driver stuff, how we represent it in the database. At a higher level, you should only care about volumes, number of volumes, gigabytes, and if you want to consider as well the volume types. We can see it in a couple of examples later if people want. So the code, the spec proposes this transaction mechanism, and we already had in the context, in our everyday context, a mechanism that allows us to move this transaction throughout our code. So you can create a transaction at some point, in let's say put it in the context, and then move it around. And that is what the implementation is going to do. So let me share a screen for a moment so that I can show. Let's see if I can do it. This one. Okay, so here I'm hoping everybody's seeing it. We can see how this would look like. Instead of the whole code that we have, in the version object, for example, let me go to a simpler one, because that one is a little more complex. For a group checkup, we say quota, this is in the group of version object, okay? In the create method. Here, create group Oslo version object. So what it does is calls the context manager to check the quota with the context and says quantity 1. So what this is going to do is start the transaction, check the quota, and then allow the code to go into here. That creates the entry in the database, but it's going to be done using the same context. So the session is carried along here. This removes part of the problem of having to roll back and the reservations, it's everything. This is all the same thing. This is treated as a single transaction. The transaction finalizes as soon as the context manager exits. And the interface of this quota driver, the context manager, explicitly states that this has to prevent race conditions with other checks. So the driver, when we call this and it goes inside to the group create, this does a mutual exclusion and nobody else can be checking groups. Because otherwise we have the problem, you do two concurrent checks at the same time and they both commit, and by commit I mean create the results, because here, since we are dynamically counting things, as soon as you create the entry in the database, the record, you have committed your quota. You're using that. In this case, if we create a group, as soon as it is created in the database, you will have the count will go up by 1. And that is why the group check context manager needs to log others, because otherwise, if you only allow 2, you only have 1, 2 concurrent requests come in, they check and they say, okay, I want 1, there is 1, I can proceed. They both could go forward with the creation, and now we would have overcommitted, because the check, we could do concurrent checks. The way it's going to prevent the checks from happening is by selecting for update the limits that we have. So if we have 2 tables, the quota classes and the quotas. These are the hard limits. These are not countings or anything. These are actually the limits that we set in here. So it's better to better follow this. Let's say the quota classes table stores the global system defaults. So even if a project doesn't have anything set up, the defaults are stored in the quota classes table. There we have all the defaults. And the quotas are the hard limits for specific projects. And they work as an overlay. You have the quota classes table, and everything that is defined for a specific project replaces what it's in the default, basically. So by doing a select for update on those, you create a log, because all the checks do selects for update on those. So there cannot be to select on those tables, select for updates, happening at the same time. The first one will pass, the second will wait until the select for update completes. Thus, we create a log in the database. The log that is inside the transaction. So if we look at it, I'm going to try to show it with a picture. Hopefully it will be, I don't know, it will be kind of easier to follow, but I'm not entirely sure that my drawing skills are going to be up to it, but let's see. So it should be here. So this is our Cinder database, and we have the quota classes table, the quota table. We have here volumes. We have a snapshot. Let's see. Okay. So in the quota classes, these are the defaults, and we are currently creating most of this on the migration. So we will have volumes. If I remember correctly, this is set to 10 gigabytes. This is set to 1,000, and so on. There are a couple that are missing. For example, the backups, and one of the patches that I propose adds them so that we would have them as well. And then the quota needs to have, for example, the project for project 1. We can say that the default for volumes underscore LVM is 5. And that, again, for project 1, volumes is set to 9. This means that when we start in the context manager to do the check, so is check, I think is probably the other way around, check group, context manager. So we enter the context, we start the transaction, and we do a select for update on this, on all this. This basically creates a lock here. That prevents any other requests from accessing because it's going to select the same resources. But for example, if we have backups here, this is not selected. So backups can happen concurrently because they don't need the same quotas. So the lock does not affect us. We select this, we get the limits in Python. Now we go and we do the counting. And for this counting, it has to go to volumes and also to a snapshot. In this case, because we have gigabytes, and by default, we count snapshot gigabytes as part of the volumes. So they add up. So here we will have a query that checks for that the project is 1, checks that the use quota is set to true, because otherwise we don't count those, and adds counts number of volumes in gigabytes. And for the snapshot, it will count the gigabytes for the specific project. So, and we can do this in Python. The get limits count and then decide because of the lock. Thanks to this lock, we can do this in Python without having problems that another comes in. Now we decide and we say, okay, well, sorry, this is not group, this is vol, because otherwise this doesn't make any sense. So we decide and we say, okay, everything is okay. So now we create the volume. We go here and we insert. We exit here, and this is the commit. Everything is done, and we don't need any kind of create reservation, create volume, commit reservation. We don't need to do anything. We don't need reservation for most of the cases. The code would do this. This part happens. Decide, okay, this part, it's in the oval, in the version object. Like I think I showed here. This is the create, and the start transaction, select for update, the counting, and the decision. All this happens here in the group check or volume check or whatever we want to check. This is the general idea of the code. Now, originally, I was too optimistic and I said, oh, we don't need the reservation tables because we can do it just like this. But it turns out that there are some operations that cannot work this way. A very simple one is volume extension. You have a 1 gigabyte volume, now you want 2 gigabytes. What happens? What happens is that the counting, as we said here, the counting happens with what we have in the database. but the request comes in at the API and should fail at the API if there is not enough quota to extend one volume from 1 gigabyte to 2 gigabytes, for example. It should fail. And we can do the check. But as soon as this transaction finishes, the select for update stops. So somebody else could go and use that gigabyte for a new volume. So for example, in extend, we will need to use the reserve and reserve 1 gigabyte for the volumes, sorry, 1 gigabyte, 0 volumes, so we don't need to create this one because volumes, we are not adding anything, but we will also need to create 1 gigabyte of the volume type. In the end, I think there are 3 operations that require reservations. If I go somewhere in here, I talk about them, and then extend, like I mentioned, because at the API, you say, I want to increase it, but it may fail. So we end up with the reservation. Transfer, because, in this case, it's because there is a driver that needs a callback when we are doing the transfer. Usually, we would not need a reservation here, but because we have to check, go to a driver, and then complete the database changes, we don't know how long the driver is going to take. And it could not be a smart thing to do to block all other concurrent operations with the select for update while the driver is responding, because it may take, I don't know, 200 milliseconds. I don't know how long the storage array may take to complete the operation. So to make sure that we are not taking too long in the critical section, what we do is use reservation for the transfer as well. On the case of the retype, we don't need to reserve new volumes, new gigabytes. We need to lock those only for the specific type that we are going to use, because during our retype, we want to be using reservations in 2 places. We want to be using them in the source type as well as in the destination. Why in both places? Because we can fail. And we decide, let's stop using the reservations from the source. But what happens if the operation fails and we have to go back and leave the original type? Then we could overcommit again. By reserving in both, creating reservations in the new type, we are ensuring that whatever happens, succeed or fail, we will never overcommit. And probably there is one question that may arise to people that are aware with the problem with reservations, and that is, reservations are a pain, because if Cinder goes kaboom, and suddenly the reservations are left there, we originally created a periodical operation that every 24 hours or something, every couple of minutes would check and see if a reservation had been there for 24 hours, something like that. If they were there for that long, it clears them. That is the current mechanism that we have. The idea here is to not do that. Instead of having something that periodically happens, the idea is we have something that in general operators use, get things unstuck. And that is changing the status, the reset status operation. For example, if you have a volume that it's extended, for some reason it breaks in the middle of the operation, you have the reservations. Instead of having to wait 24 hours for them to actually clean automatically, there will be code when you say reset the status of this volume to available, that was before. then it will automatically clean the reservations. That way, an operator does not need to play around with the reservations or anything. Just by changing the status will fix it. That is the general idea, and since it's a bit complicated and I'm not sure I explain it too well, I would like to hear if there are questions and things that are not too well explained.
The general concept makes sense. I'd have to spend probably days studying the details to be able to provide meaningful, specific technical feedback. But at a high level, it certainly is apparent, you've thought the entire problem through and seem to have a general solution to handling quotas and not just play whack-a-mole with individual bugs, which is how we've gotten here today. So I can't ask specific detailed questions, but, thumbs up for me.
Okay. There are a couple of things that I've done that probably I would like to point out. It is a mention in the spec, but they are, for example, right now we have the quota driver code has SQL or SQL alchemy or SQL queries that are in our Cinder Database SQL API file. And what I'm doing here is moving everything from there related to quota and moving them to a specific quota driver. Why? Because if it's going to be a lot easier to know, okay, there's something wrong with the quota. Let me go to a driver that has all the SQL queries and it's in there. And if it's not in there, the problem is either that the version object code is wrong or that whoever is calling the version object is, for example, not setting that this is a temporary volume. So it's getting counted because they didn't set it as temporary or the other way around, things like that. It's pretty, even, so let me make this. I'm sure I'm going to introduce bugs. I have zero doubt. What I think is that it's a lot easier to find it out. It's going to be easier. And second, this is easy to reproduce. Why? Because we're dynamically counting things. If somebody comes to me and say, hey, the quota is not turning the right values, I can just say, show me what you have in the database, and I can see where the code is failing. Right now, when somebody says, this is out of sync, I have literally no way to figure out when and where it went wrong. With this, at least we can say, okay, this is what's wrong. Because with your data, I forgot to take into consideration this case. And I see the query, it runs, it doesn't match. And I can actually fix things easily.
Well, this is the classic, consolidate all of the critical code in one area where it can be managed. And, right now, the code that wants to, fiddle something with quotas is all over the place.
Exactly. That is part of what the patch and the spec proposes is remove from all over the code, all of the Cinder services, the quota code, move it to the version object, part of it, and then to the driver. And that's it. That's all you need. Whoever needs to use quota, they have the driver, or they use the oval version objects, which are, when you create a version object, it automatically will do the quota checks. You forget about it. So we will remove cases where we suddenly forget to count it, not count it. We don't care. Done automatically. So it is a deviation from what we currently have, which is have all the database specific code in the API file of the database. But I think to me this makes sense because it also allows us to fiddle with it. For example, at some point we will have to change to unified limits. The keystone feature that Rajat mentioned that I had forgotten to explain in the spec. At some point, we will have to do it. So most of the code in the Cinder in the database driver will no longer be relevant. And we can even have both drivers simultaneously, doesn't matter, because each one will have its own file, it will be independent, and I think it will be better. But that is a deviation that I am proposing to do, and maybe people will oppose. I don't know. What else? Okay, there is one thing that is going to happen in this scenario. As I explained, we're going to be doing select for update of two tables, the global default and the per project specifics. This means that we are using the same lock, which is the global tables, for all the projects in Cinder. Yeah, exactly. That is not great. It is going to be fast because the critical section that is locked is very small, but still, we are introducing a bottleneck there, which is not nice. And in the spec, I propose a couple of alternatives. I don't really like any of them. So right now, the implementation is with the bottleneck. And I'm going to do performance testing and see how it goes and whatever. But the two proposals that I have is we can we basically would have to duplicate this, the information that we have. The defaults, we would need to duplicate it so that not all the projects lock against the same thing. There are two places where we can duplicate it. In the Quota classes table, right now, the Quota classes table has a class name, which is default, and that is everything we support. We don't support anything else. The original idea, in case somebody wonders why we have this Quota classes thing, is that we would support different classes, and each project could have its, let's call it like volume types. You have a volume type, well, you would have a Quota class. And then you would have the high performance Quota class that has defaults, but we could still overlay a different project, a specific one. But at least you could say for this department, which each one has its own project, it makes sense to have a Quota class. That was the original idea. So you would have the default, and then you could provide this for each project, have to use a different global default, and then they could even have a specific limits for that project. That was the original idea. It was never implemented. It has not been finalized in Nova either, and it's been like 6-7 years since this was added, the Quota classes thingy. So what we could do is we could duplicate the default, the global defaults for each project that comes in to Cinder. In that way, instead of the class name, we would use the project ID. So when they ask us, we try to retrieve the information. If there is no default for the global, we have to duplicate them, and then try again to do the select for update. The other alternative is basically, instead of duplicating it, the Quota table, in the Quota classes table, you duplicate it in the quotas. And you have to mark which ones are using default and which ones are overlays. So we would have to add a column, a Boolean column that says is default or not. But in any case, if we want to remove this bottleneck, we would have to duplicate the defaults in one table or the other. That's the only solution I could think of right now.
This is a stupid question, but can you explain why we need a lock on the Quota classes when we're doing the transaction? Because you'd think that would be a read-only thing, but
yeah, it's a read-only. We are not going to be changing it, but the lock, let's say I deploy Cinder right now. There is no per project default limits. There is only global. but I still want to prevent a specific project from going over it, from getting too many 20 simultaneous requests of create volume, and the default, the maximum is 10. The checks come in at the same time, you're going to overcommit. You can only, okay, so let's say limit 2 volumes, okay? Or limit 1 volume. And that's the global default. I don't want anybody to own more than 1 volume in my, that's the global in quota classes. I just deployed and there is no per project default. There is, I'm in my project, I launch to create volumes concurrently. They both check the current limits. They say the limit is 1. They both go, they both count, and they say there is 0. Awesome, I can create my volume. They both go and create the volume. And now I have overcommitted. So the only way to make sure that you are not overcommitting is having one single per project and per resource, one single operation at a time while we create the resource that is being counted. Because as soon as I create the volume, the dynamic counting will say, oh, now there are 2. I jump from 0 to 2 on the next check, and now I have overcommitted. What happens, for example, Nova? What does Nova do? Because they are in the proposal of the unified limits, where they cannot do this select for update because the limits are being asked to Keystone. They say, hey, Keystone, give me the limits. Then they do the counting and they say, so this is Keystone, this is Nova. They ask, they get the limits, they do the counting, and they decide here. But they can go over quota because they have the race condition. So what they do is after committing, they do another check. They say, hey, have I overcommitted? Yes. Then rollback, failure. I don't want to have this case because then you have false negatives. Again, if you have double race conditions where 2 create at the same time, they check at the same time, they both will think that they are the cause of the overcommit and they both will fail. It doesn't. I'm not too sure that is the best approach. This try and this, check, try, and we may have overcommitted, let's roll back. No, not rolling back. You have to make sure that you have enough quotas to commit them quickly, and there you go. And in most of our code, the commit is really fast because it's just create a volume, for example, record. That's trivial. There's not much to do there. Create a snapshot, whatever. It's a database request, a bit of Python, a lot, not too much of a deal.
And to that end, I wanted to ask, you mentioned that, we've got a bottleneck and possible additional changes. How do we quantify the impact of the bottleneck? I mean, is this one of those, there is a bottleneck in the sense that everything kind of flows through this neck. But if everything is flowing through so quickly, are we solving a problem that really won't have any, performance benefit?
That was my original line of thinking, exactly. As in, it's linear. The number of requests that we can process here is going to be linear. But maybe the number is so high that we don't care. And this is similar to what Walter said with having multiple schedulers. He said, here we only have one running simultaneously, and we've never had any trouble. Speed performance bottleneck. And in theory, it's a bottleneck, but they don't experience it because everything flows fast enough. And that is what I think is going to happen. We're going to be so much faster than what we have now, because in the spec, I even go over the difference in the number of requests that were happening before with how many are going to happen now. And it's a big difference because before, first of all, we were checking each of the limits one by one. we were saying, hey, give me the gigabyte limits for gigabytes, give me limits for volume type gigabytes, for volumes, for each is one request to a database. Now we just make one and we get everything from both tables. So then we had to create reservations, one for each of them. Boom, boom, boom. Then we have to commit them, and it's like over and over. And if you have to roll back to more changes, it's the number of database requests that we're going to be making now. It's a lot smaller than before. And I even had a huge SQL query that did everything simultaneously on the database. It checked both tables, the limits, it counted and returned the numbers that were failing. But I didn't propose that solution. This can be a future driver, whatever, because the SQL is more complex. It's harder to debug. Here it's somewhat easier to debug because we have one query that is give me the limits, give me the counts, and in Python I do the difference. It's slightly less efficient, but it's easier to debug, easier to read, and I think for now it's probably a better idea not to do that optimization.
Yeah, that I think that makes a lot of sense, because then we can optimize later once we know everything's working, if we need to. But
right.
And my next step would be to do the performance, the actual performance, and to Alan's point, see if this is actually going to be a problem in terms of not being able to have to be able to separate the different projects, because maybe the number is high enough or is so much better than now, it doesn't matter. Yep. But that is definitely something to take into consideration. And I will probably try to make a small proposal of the, like kind of a draft of what the unified limits would look like with the new quota driver interface. So we can at least do a quick check that we would still be able to support the unified without having to rework everything. Because if we have to rework everything, this is not going to work.
yeah, that would be helpful.
Mm-hmm. Okay. I tried to go over everything in the spec, all the corner cases, I explained the retype and everything, but I also have the code, a POC code with the driver, how it would look like, the methods, the implementation, and everything. So I'm hoping that helps a little bit to also see it, and we can all. It also helps to see how much cleaner the code is going to look. Let me see if I can. Okay. Let me show you quickly. Well, it's not going to be quick because it's me, but anyway, I want to show a specific thing that I think it's kind of makes it good to see what we are talking about when I say that this is going to help make the code more readable. I think it's this one.
Yeah, and if anyone's listening to the recording, the links to the proof of concept patches are in the Yoga mid-cycle Etherpad. So
yeah, and they are also in the spec. I
excellent.
try to make it easier. Let's see, Cinder transfer API one. So let's see if I can share my screen and show this one. I think this is the one. Okay, so this is the Cinder transfer API. And on the left, you can see how much code we have in the Cinder transfer API. So this is API level stuff. On the left, you can see all the code that we have for the quota. In there, everything that is read. For example, in this method, in this specific method, the accept, the new code is going to call the star accept transfer code in the version object of the volume, and we are removing all this stuff where it says per volume gigabytes, volumes, gigabytes. It's all this stuff that makes it, on the left you can see everything here that it's making it, the commit quotas, the rollback quotas, all this stuff is making the code so hard to read, because it's hard to tell what is actually doing the high level stuff and not fighting with quotas.
Which is why it was buggy and fragile.
Yeah, it's so hard to write new features when you have to worry about the quotas all the time. All this is, I think they mentioned here in the spec, 106 lines of code. Only 36 are relevant to the actual operation of the code. Everything else is quota. That makes it so hard. Here, we start, accept, transfer, refresh, finish. That's it. I think this is slightly easier to follow than the other one. And sure, we have a little bit of quota code in the volume. Of course, the objects volume. Of course, we are putting it all here. So here is start, accept, and finish, accept. Even considering the amount of code that we are adding here, it's still less than what we had before. But anyway, I think it makes it a little bit more readable. I'm hoping. Maybe when people start reviewing it, they can propose better ways to write it, but at least I think it's a step in the right direction, pushing everything out of the high-level manager and API and everything.
No, I like it. It looks good. Okay, we're pretty much over time.
Yep, sorry about that.
No, that's fine. We'll have the recording for anyone who missed the meeting, so that's great. Any last minute observations before we wrap up? Okay, great. All right. Well, thanks, Gorka. This is
Good stuff.
really good, and we'll have the recording so everyone can participate. I'll go ahead and stop it now.